In the previous video, I showed how to start an example application running on a Raspberry Pi with the IzoT SDK installed. In this video, I'll show you how to create an IzoT network with multiple Raspberry Pi devices and the multi-DIO application that I showed how to start in the previous video. For this video, I'll be using this setup. I have 3 Raspberry Pi devices, each one with a Pi-Face digital I/O board plugged into it, installed in a case. The 3 Raspberry Pis are all connected to a standard router/access point to create a network, and that router access point is acting as the DHCP server, assigning addresses to those devices. And my PC that I'll be using for the demonstration is also connected to the access point through Wi-Fi. The multi-DIO application running on multiple Pis demonstrates how you can create applications for devices that automatically discover each other and automatically communicate with each other. The multi-DIO application, as we're running it here, does not require any separate server or installation tool. All I am running are these 3 devices, and I'm using the PC to load the applications, but I'm not using the PC to create the network. The devices themselves will do that. So for this application, I'll run the same application on all 3 of the devices. I will make a one-line change to one of the devices to designate it as a host. That will host the connections between the devices. And once the devices are connected, I'll be able to push a push button on one of the devices. You can see each one has 4 push buttons. I'll be able to push a button on one device and have the corresponding LEDs light up on all 3 devices. And I'll be able to do that for any one of the devices. So I can push a button on any one device, and in every case, all 3 will illuminate their LEDs, indicating that the devices are connected and communicating and had discovered each other and had verified that they're compatible with each other and created connections with each other. This is the PyCharm IDE. I've started 3 console windows within the PyCharm IDE as I described in my console video. Each one of these is a console for one of the 3 Pis. So you can see I have .60, .61, and .62. So 3 Pis running Linux, but not yet running any applications. What we will do first is modify the multi-DIO application on one of these Pis to designate it as the host. To do that, I'm first going to open a remote host window. So here's the remote host window. So I'll click here on the right. That opens the remote host window. From within this window, I can select a host. So you can see my 3 DIOs are here, 60, 61, and 62. So I'll select 60. So this window on the right is a view into the file system on the selected remote host. In this case, this is the file system on my DIO. On the left side, I see the file system for my PC. So what I'm going to do is navigate down into the file system on my Raspberry Pi. So I'll go into the IzoT SDK directory. I'll go into the IzoT directory below that, and then the examples directory, and finally the multi-DIO directory. So this is the multi-DIO example directory, and here's the source code for that example. Now the source code is sitting on the Raspberry Pi. I want to get it onto my PC so I can change it. To do that, I right-click on it and say download from here. So when copying a file from a server to your PC, that's considered a download by PyCharm, because the server is serving the file to the PC. So I right-clicked, I said download. As you see down here at the bottom, it says the download was completed, one file was transferred. I have a little notice here about the file transfer as well. Now if I go here under IzoT SDK First Project and expand it, you'll see it's created the same directory structure beneath the project directory that I had on my target Pi. And here is the file I just downloaded. If I double-click this, that file is opened here in the middle pane. If I scroll the middle pane down, one page, I see this line of code here that says is host device equals false. So what I'm going to do is just change this to say is host device equals true, designating this one Pi as the host device for my network. Before uploading the file, I'm going to change the permissions on this particular file because I know it's one of the files installed by the IzoT SDK. The permissions are set to make it read-only. But I can say right within PyCharm, I can say change permissions. I can say make the file writable. Click OK. If I right-click within the middle pane and select Upload To, I'm given a list of all the devices defined for my project. In this case, I'm going to select DIO60, which is the device that I originally downloaded this file from. And this will upload the file back to the device. I get a message here at the bottom saying the file transfer has been completed. And I see here in the log that the upload was completed. So now this file has been updated on one device, and the other 2 devices are still the same. So the next step is to start the application on each of the devices. So I want to go back to down here at the bottom. I'll click on Terminal, to see my console windows. I'll start the applications directly from the command line for all three of the devices. So to do that for each device, I'm going to change to the appropriate examples directory, which is IzoT SDK / IzoT / examples / multi DIO. Once there, I'll just simply say supy multidio.py and start the application. I'll repeat that 3 times for the other 2 console windows. And now I've started multi-DIO on the third Pi. So I have the multi-DIO application running on all 3 Pis. We can go back now to the first one and look a little bit at the console log and see what's happened as it started it up. So it tells us the application started, the program ID, the unique ID, and of course unique ID will be different for each of the 3 Pis. And for one of these, it's going to tell us right here that the host device is true for this application. Whereas if we look at the other 2, and we scroll up a little bit in the logs, we'll see host device is false there, and on the third one, host device is false there. So I have 1 host device running and 2 non-hosts running. When the application first starts, the devices aren't yet communicating with each other because they need a little bit of time to discover each other. So if I push the first push button on the first Pi, you'll see in my log window that the output is changing between on and off each time I push it. The other devices aren't yet responding. So we'll wait a couple minutes for them to discover each other and create the connections. A couple minutes have gone by, and now if I push the first push button on my first Pi, you can see the console window for the first Pi saying I'm pushing the button. But as I look at the other 2 Pis, I can see the first LED on the other 2 Pis changing state as I push the buttons. You can see that here in the console windows. So if I switch to the second console window here, and now I go back to the first Pi and push the button, you'll see the second Pi reporting it's turning its output on and off. If I push the second button, then it says it's turning the second output on and off. And same thing if I go to the third Pi. Here I'm on the third Pi, but pushing the button on the first Pi, again the first push button on the first Pi, and I see output 0 going on and off. Second button, I see output 1 going on and off. So I've created a network of 3 Raspberry Pis running the IzoT SDK multi-DIO example application. After running the application for a couple minutes, the devices discovered each other, connected with each other, and now they're fully communicating. Once those connections are created, they're permanent until changed by the application. So if I shut down the devices and restart them, if I ran the applications as a service, as I showed in the previous video, the applications would automatically restart. They would already know they're connected to the other applications, and so the full connectivity that we see now would still be there as the applications restarted. In this video, I've shown how you can create a community of communicating devices using Raspberry Pis and the IzoT SDK. The example that I showed as part of this video is the multi-DIO example that allows multiple devices to communicate with each other and demonstrates how I can push a button on any one of those devices and have equivalent LEDs light up on all the other devices. That's only possible with the power of the IzoT SDK and the Long Talk IP protocol.